conversion of snow to glacier ice. The new and freshly occurred snow is varying porous, having a density less than a tenth that of water density. Air easily penetrates the pore spaces where the delicate points of snowflakes gradually disappear through evaporation. The resulting water vapor then condenses mainly in constricted places near the center of the ice crystals. In this way, snowflakes gradually become smaller, rounder and thicker, and the pore spaces between them disappear. When fresh snow's permeability is decreased, the air pores get disconnected and the mass is referred to as fin or neve, and the densities increases from about 0.1 grams per cubic centimeter to 0.5 grams per cubic centimeter. The fin is an impermeable, structureless and dull white form of ice mass. When the weight on top of it rises, the pressure the fin turns into ice. This has very few air pockets and a blue sheen. Ice is awfully unusual stuff from snow, plastic in nature, and under pressure it can be deformed. When thickness of ice achieves about 100 to 200 meters, motion begins in it towards downslope, and this moving ice river is termed as glacier. At times, a small glacier which may originate from snow patches is known as glacieret. Classification of glaciers. There are several types or forms of glaciers and they differ in size and originate differently. The glaciers can be classified on the basis of their extent and form, morphology and regime of internal temperature or thermal characteristics, etc. Ullmann, known as a grand old man of international glaciology, has presented classification of glaciers in the year 1948 on the basis of morphology, that is location and shape. However, for sake of simplicity, the Ullmann's glaciers classification was neglected. In general, glaciers can be broadly classified into three types. They are continental glaciers, valley glaciers and Piedmont glaciers. Now, we begin with continental glaciers. Continental glaciers are also known as non-valley glaciers, which cover extensive areas in continents. These glaciers have different forms such as ice sheets, ice caps, ice domes, outlet glaciers, ice shells and ice fields. Ice sheets. They are the largest glaciers on the surface of the earth. These masses of ice resembles as much as of continents, overwhelm almost all the land surface within their fringes. Mostly the modern ice sheets are restricted to Antarctica and Greenland and together encompasses about 95% of the entire glacier ice on our planet. The combined estimated volume of them is nearly accounted 24 million square kilometers, would be adequate to increase world sea level by around 66 meters if the whole melt out. The ice sheets of Greenland that resemble the area which almost equal to the area of United States situated to the western part of Rocky Mountains. They attain such a high thickness about 3000 meters that the crust of the earth below much of it has been depressed below sea level by its weight. Along the high trans-Antarctic mountains, two massive ice sheets merge to cover Antarctica. Covering the continent of Antarctica, the Antarctic ice sheet is the larger of the two. It is the only truly polar ice sheet on the earth, for the North Pole lies at the center of the deep Arctic Ocean, which is covered only by a thin layer of sea ice. Antarctica has the lowest average temperature and the highest average altitude of all the continents due to its ice sheet. Numerous highlands in the Antarctic archipelago are covered by the smaller West Antarctic ice sheet, while large swaths of it cover territory below sea level. Some parts are situated on land that rises above sea level. Ice caps. The smaller types of ice sheets with an extent lesser than 50,000 square kilometers, which are confined by surrounding topography that controls their shape and the direction of movement. The majority of the smallest glaciers are found on the Arctic, Iceland and Norway. Greater glaciers extend downward onto floors where their shapes are determined by the bedrock environment. Generally exhibiting radial movement, ice caps of different sizes cover lower lying areas at high latitudes. The best examples are Barents ice cap and Baffin Island ice cap, etc. Ice domes. The central part of an ice sheet or ice cap, which is dome shaped, attributed by symmetrical to parabolic shape with a thickness of 3000 meters and associated with outlet glaciers, is termed ice dome. Outlet glaciers. These are ice streams that frequently travel through enclosing mountains and drain a portion of an ice sheet cap. They are constrained by the terrain, much like the valley glaciers. Outlet glaciers are forced through mountain passes at comparatively high speeds that are noticeable due to pressure that builds up in the ice behind a mountain range. They are common around Vatnajökull ice cap in Iceland, Greenland and Antarctica. A good example is the Jakobshavn Glacier, which is flowing into Disco Bay on the west coast of Greenland. Ice shelves. The thickest floating ice sheets attached to the coast are known as ice shelves. They occur at various places along the boundaries of the Antarctic ice sheets and locally in the Canadian Arctic islands. These are mostly situated in large coastal environments, are connected to land on one side, and their seaward periphery usually forms a steep ice cliff elevating as much as 50 meters from the mean sea level. The greatest ice shelves cover several hundred kilometers from the coastline to seaward, which accomplish with at least 1000 meters of thickness. Ice shelves are supported by streams of ice flowing off the land and by direct snowfall on their surface. The best example are the Ross and Ron Fletcher ice shelves in Antarctica. Ice fields. They are relatively flat and extensive masses of ice in the mountainous regions, which consist of many interconnected alpine glaciers. They are lack in domal shape of ice caps. Their flow is strongly determined by the underlying topography.